Hi everyone. In this video we're going to be discussing two new rules, the commutative rule and the double negation rule. Now one thing I want to say before we start is that in the beginning of this course I said that what we're doing now, natural deduction, was going to be split into two different sections. Those two sections were the rules of implication, which are 8 rules, the first 8 rules that we finished, and the latter half was going to be the 10 rules of replacement, which we're starting in this video. So the difference between the two is that the rules of implication are like arguments which imply their conclusion, and the rules of replacement are logically equivalent arguments. We did a video earlier in truth tables where we compared two arguments that were logically equivalent. So any of those, not arguments, I guess, two different types of propositions that are logically equivalent. So any two types of propositions that are logically equivalent will be able to replace one for the other, and hence they're called the rules of replacement. So now we got that out of the way, let's start introducing the rules. So the first rule is commutative. So commutative, again, it doesn't have we're not going to have the slashes or the double slashes like we did, because we're not making an argument. Instead, we're going to use this thing called the double colon, which implies logical equivalence. So commutative is like one of the ways of formulating it is if you have not if P and Q is logically equivalent to Q and P, right? The same thing as saying Brian and Jackie is the same thing as saying Jackie and Brian, right? This also works for the OR operator. P or Q is logically equivalent to Q or P. You know, Brian or Jackie is logically equivalent to Jackie or Brian, in the same way. So, I wasn't formally introduced to this, but you could also do P if and only if Q is logically equivalent to Q if and only if P. And the reason you can do this is because one of the rules of replacement we're going to learn later is called material equivalence, and it's going to allow us to simplify the biconditional operator. And it has two forms. One of the forms uses the OR operator, and the other form uses the AND operator. And as we've shown right here, we can use commutative on the OR operator and the AND operator. So even though I didn't formally learn this, the two should be logically equivalent. Alright, so let's take a look at this a bit more in depth. So let's say we have, let's say P or Q and R. So we can do a few things here. We can switch Q and R or P. That's the first possibility. Or we can get P or R and Q. And so in the first commutative, this one right here, what we did is we just commuted P or R. We used the OR operator, and we flipped both sides of them. In the second commutative, we used it in the parentheses. So we commuted this AND operator right here. And we got R and Q. And it would work the same way if you had, you know, P and Q right here, and then R and S right here. We could commute both of those too. So that's how the commutative rule works. You can commute the main operator or operators within parentheses as well. Alright, so the next rule we're going to describe is called the double negation. So let's take a look at how this works. Earlier we introduced modus tollens. I don't need to introduce modus tollens to show you how the double negation works, but that's the example I'm going to pick. But it just occurred to me that I haven't introduced the operator yet, so I'm going to do that right now. So double negation works this way. P is logically equivalent to not P, right? And it's really easy to show this in a truth table. So let's say we have, let me put this right here. Let's say we have P right here, right? And we have a negation, not P. Now, earlier when we showed that something is negated, we showed that the negation gets priority. So the negation would be true, right, if we only had one. But since we have two negations, this negation's true, right? Because the P that was being negated, its negation's on its left side. So in this case, the negation is being negated, and the negation's negation is on its left side. So the negation's negation is true. And if the negation's negation is true, that means that the negation is false, right? Because if this is true, then this has to be false. But if this negation is false, that means that this is true, right? So P is true. So saying that P is true is the same thing as just saying P. And so that's how the double negation works. Take a look at an example. So the example I was saying a moment ago with modus tollens, P, P then not Q, and then we have, let's take this in the form of an argument. Let's say we have P then not Q, and our premise is Q, right? And let's say we want to get not P. Okay, so how do we do this? Well, it looks like we could do modus tollens, right? But we haven't been taught how to use modus tollens with just a regular premise like this. And so, if this was not Q and this was Q, you could see that you could do modus tollens. And so as you might guess, we do it with the double negation command. So, let me fix this. So, for premise 3, we get not Q. And now we have the negation of the negation right here. So this is not Q, this is not Q. And after we get not Q, we can get not P. Let me just justify these rules, these lines, I should say. So this one we get not P through 1, 3 modus tollens, and we get not Q. We get not P through 1, 3 modus tollens, and we get not Q through 2 double negation. And I mean, this works in the same way for similar rules like disjunctive syllogism, or disjunctive syllogism. That's the only one I can think off the top of my head. Yeah, but this is just a quick introduction to the rules, and I'll see you guys in the next video.